Question 14, we're shown two sequences and asked to find the next term and the nth term of either, of both. So the nth term, this is the rule, how do I go from one term to the next? And the next term is what's coming up. So to do the next term, let's look at the common difference, what's happening here. Well, firstly it's going up by 4, then by 6, then by 8, then by 10. So the next one is going to be up by 12. So 25 plus 12 would give me the next term of 37. Then it says find the nth term, which again is the rule. So I can tell that this isn't linear because the first difference isn't increasing by the same amount each time. So in that case we go on and we look at the second difference, and the second difference here is 2. So if the second difference is the same, this tells me it's going to be a quadratic sequence, or in other words, the rule is going to be an squared plus bn plus c. The one thing you have to remember here, and we did go through the proof in class, I won't go through it again here, is that the second difference is equal to 2 lots of A. So in this case the second difference is 2. So if 2 equals to 2A, then A equals to 1, which means that my sequence is just going to start as n squared. And then from here you can do it a number of different ways, but if I know that my sequence is going to start as n squared, let's have a look at what n squared would give me for the first term, the second term, third term, fourth term, etc. So the first term, if it was n squared, would be 1, and then 4, 9, 16, 25, and so on. But that's not the sequence that I want. The sequence that I want is -3, 1, 7, 15, and 25. So in other words, I'm going to start with n squared, but I've got to add on the difference. I've got to add on what takes me to my actual sequence. So let's look at the difference between each of these. So 1 to -3 would be -4, 3 to 1 would be -3, 9 to 7 -2, 16 to 15 -1, and 25 to 25 is just 0. So I need to add on to what I've already got, which is n squared. I need to add on a rule for this sequence here. If we look at this sequence here in a bit more detail, -4, -3, -2, -1, and so on, this is a linear sequence, and I can tell because it's increasing by the same amount each time. The first difference is the same, it's going up by 1s. So that means it's just going to start as 1n. We also talked about it graphically. We said if it's linear, it's going to be a straight line, it's y equals mx plus b, and the m is the gradient, how much the sequence is going up by. So this is going to start as 1x or 1n. And then we said, well, how do you find the plus b in a linear graph? Well, that's where it crosses the y-intercept, or in other words, it's the 0th term. So if x was 0, if n was 0, where would I start? Well, instead of going up by 1, if I go to the right, I'm going to go down by 1 because I'm going to the left. So it'd be 1n minus 5, or just n minus 5. So remember I had n squared to start with, and then I said to you, well, we have to add on this other rule that we get from the middle here, and the other rule is n minus 5. So it's n squared plus n minus 5. And then with part B, if you've got a sequence with fractions in it, look at the numerator and denominator separately and see if you can see anything going on. So if we look at the numbers on the top, my first term was 1, the second was 8, third 27, fourth 64, and so on. And this is a special number set. These are the cubic numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed, 5 times 5 is 25, times another 5 is 125. So I know that my next term is going to have 125 in the numerator. And in the denominator, well, I don't recognise these numbers, so let's have a look at the first difference. They're all going up by 5s each time, plus 5, plus 5, plus 5. So if I plus 5, then the next number will be 22. So the next term is 125 over 22. And similarly for the nth term, we're going to look at the numerator and denominator separately. So if we talk about the numerator again, which was this part here, we said that these are the cubic numbers. No matter what n is, if I want to get the term, the numerator, I just cube it. So the numerator, the rule is just n cubed. And then on the denominator, because the first difference is the same, it's going up in 5s, this means it's a linear. So again, it's going to start as 5n, or if you like to think about it graphically, the gradient of the graph is going to be 5. And where's it going to cross the y-axis? Well, instead of going up in 5s, I need to go down in 5s. So 2 minus 5 would take me to -3. So the rule on the bottom is going to be 5n minus 3.